So we're there. Well, the idea is to have a technical talk about Apache Kafka, which is a distributing commit log service. Also can be used as a messaging system. The idea of the talk is to spend a little time together talking about technology and coming up with new ideas of things that we may going to need in the future for helping the business. So yeah, I think that's it. Let's start. Let's talk a little bit about Kafka. Kafka is a distributed, partitioned, replicated commit log service. It means that messages are always being appended to the log, and then all interested on these messages can be reading from the log. It provides the functionality of a messaging system. We are going to see what a messaging system is in future slides. It was created by LinkedIn, then contributed to Apache in 2011. It's written in Scala and has multilingual support, multi-language support, sorry, for its publish subscriber API. So I don't know if you can see it well, but the idea is to have here an example of what a messaging system is. The idea is to decouple the data producing with the actual data processing. So I'm using myself. So in that case, what we have here, it's an application that has the responsibility of consuming data and then publishing, and then we have another application completely decoupled that process this information. Something a little bit more robust would be to have a message broker in the middle between the publisher and the subscribers, so we can publish multiple messages and we can have many of these processors subscribe to those messages. So processors do completely different tasks, completely different businesses, and probably they consume messages completely different, because there can be processes that consume messages in a batch way, doing batching, and others that needs every single message anytime. So so multiple publishers, and then we can have multiple subscribers with completely different tasks to do. But when talking about Kafka, and we have here this diagram, when we needed to know a little bit about the terminology, and in that case, we say that Kafka maintains feeds of messages in categories called topics. So in that case, if we are working with Kafka, we can have all those publishers publishing to different topics, or to the same topic, or two publishing to the same topic and another one publishing to another topic. So this is the way that we are going to group our messages, and in the case of Kafka, it's called a topic. When we talk about processes that publish messages to Kafka, we will call them producers, as well as what we call here the subscribers will be called the consumers. And Kafka itself, it's an abstraction for a cluster of multiple servers. We are going to call one server a broker. Okay? So what does Kafka have that makes it different from other messaging systems? Well, a big difference is the Kafka is prepared to have producers that are producing data very frequently. I mean, remember that it was created in LinkedIn, and they have lots of data there. So the whole structure is prepared for having a fire hose of messages constantly being delivered to a topic or a group of topics. So in the case of the producers, generally they don't wait for the acknowledgement, from the broker, and they send. I mean, because of that, they send messages faster because they don't need a response from the broker saying that the message has been delivered. But we will see in next slides that it is possible to configure the producer to acknowledge exactly the messages. So, well, this is a valid optimization, as I said, if we have a log aggregation, in the case of the log aggregation, because we need a low latency for that. So in that case, it would be good.
Yeah, but we cannot mix bands.
Yeah. Well,
if she's breaking and we're losing the messages, we're fine.
Well,
we will never realize. Oh, what the fuck is going on?
Yeah, then yeah, that's true, and that's why in terms of let's say performance, or in that case durability or consistency, you have different ways of configure Kafka to allow you to do that.
Yeah, it's cool. I think that the trade-off and sacrificing just this reliability for performance is worth it whenever you can actually recreate the data again. In the case of events, like log aggregation, I think that you cannot replicate the event. You need the logs to be able to realize what has happened in the past, what has been going on. You need reliability in your logs. Because if not, you will never be able to reconstruct the timeline and figure out what has actually happened.
No, yeah, that's absolutely true.
I mean, for example, in messages, if you are just tweeting, or I don't know, something like LinkedIn, you can always retry the request. You can always try to do the same thing again. And what's the storage format?
So, well, I mean, yeah, as we were discussing that, we can also achieve durability through replication. And then Kafka has a very efficient storage format. They don't use memory as many other Java or Scala applications. They use directly the disk. So that way they use the optimizations done by the operating system. Mm-hmm. So it would always have less memory issues than what we were having when we need to manage memory. And another thing that does when it produces, it batches as many messages as it can, and then they send them.
Is it based on TP?
No, it's based on the file system entirely. The storage entirely on the file system. Yeah, they group messages in something they call message set, so it's easier to access, and the copies of the files, I mean, are stored in memory, so it's easier for the application to access them. For consuming, they don't maintain. Well, this is something that in newer versions they are doing, but in the older versions, and as they were working, is they don't maintain the delivery status of the consumers in the broker itself. Every single consumer knows what it has read or what it needs to read. And then also for transferring data from this file of storage to other servers through the network, they use send file API, which the thing is that allows it to transfer the byte through kernel space to buffer space directly, so they don't need to copy to kernel space to user space and then go to buffer, etc. So this is another elegant solution for that. This is a quick comparison between Kafka and RabbitMQ. Kafka, because of his architecture, allows us to send more than 100K messages per second, while RabbitMQ, it's more or less in 20K per second. The design philosophy in the case of Kafka is producer-centric. As we said before, the producer is producing a fire hose of events, and by design, they don't care about if those messages have been consumed by the consumers. In the case of RabbitMQ, you understand that is the broker which manages that. So they have the delivery guarantee. The delivery state, as something that come up from the previous line, is in the case of Kafka is maintained by the consumer. The consumer knows which was the last position that it read from the log, and in the case of RabbitMQ, it is maintained by the broker. And the distribution of messages, in the case that we have a cluster, in Kafka is explicit via partitioning. So every producer must say which topic it wants to publish to, but also the partition where he's going to publish. And in the case of RabbitMQ, I understand that it is a virtual cluster, so you only have one instance of RabbitMQ, and you interact as a producer with that instance. So Kafka, it is in the documentation page you can find in the website. You can find that they have a very rich ecosystem, but there are, I have to mention that they are all projects open source, but they are not supported by the Kafka team or other teams supporting them. So we can test them, but they are not officially supported by Kafka. It includes management consoles, integrations with Amazon, and logging and metrics systems.
What's that S3 mirroring tool? It's something we can use to have one instance on premise, one instance on the cloud, and just mirror from one Kafka to the other. Or?
This is the idea. Yeah, this is the idea. Also, those are probably better versions of the mirroring tool that Kafka already has.
Oh, okay. But what do you mean by Pinterest there? Is there
they did it. Yeah, and they are maintaining it. Yeah, this is something interesting probably to look into.
Yeah, the thing is, my question is because not sure if the S3 mirroring tool is something to use like CDN later on, or you just can do it.
Yeah, well, this is an alternative that we have with Kafka. We can use we can do mirroring to Amazon if we have our data center. Well, in fact, it's a case that we will probably have with the parks, and when we need to publish something to the cloud. So when it is Kafka being used, well, they use Kafka when they have the need of a messaging system. For example, as we said before, if we need to decouple logic or if we probably need to buffer messages that are going to be processed in the future or whatever. In the case of website tracking activities, I think that Kafka was actually developed to achieve this kind of projects. They was first used for tracking website activities. Then you can use it for log aggregation, as we said, for metrics, and for stream processing. For those who are not familiar with stream processing, the idea of the stream processing is having a stream of raw data, and once you have this data, you can process it to get cleaner data and then publish it to another different stream, where it's going to be another processor and they will do its part again. So from our raw record, we can have, for example, a recommendation for a website. So mostly we will have something like this when we are talking about Kafka or about some messaging systems. We will have several front ends or publishers publishing data constantly, and different type of consumers that can be consumers that need to process the data immediately, or offline consumers, like they can be Hadoop or data warehouse, which is probably needs a bunch of data. It's probably a week of storage data, and it will process it offline in the night or something like that. So that's why Kafka is prepared for consumers that need the data instantly, and other consumers that will process in a batch way. So until now, it's everything more or less understandable. My English is going to be worse in a few minutes, so be prepared. Only that. Yeah. Worse than that.
Oh.
So before I mentioned that Kafka can be distributed by partitioning. So when we are publishing to a topic, we also need to know which partition are we publishing to, right?
What's actually a partition? It's different instances of services listening, or what's it? I don't get why.
Okay, well,
Is on the disk or what?
it is actually, first let's think about it as a logic. I mean, we have the topics which are the groups where we are going to publish, and imagine that we have a cluster of Kafka servers or brokers. So for distribute the data, we need to partition it. So imagine that we have 3 servers. Well, the partition will be replicated in each server. So and each one of the brokers will be the leader for one of the partitions. So
right.
if you are publishing to a topic and a partition, you are always talking to a leader who is going to tell you, in the case you need it, that the message is actually in this queue. And then the other servers, which are called the followers, will replicate this new message that it's in the leader, just as Kafka work, which is they are consumers from another producer that in this case is the.
As a publisher, do I need to specify partition?
Yeah. Yeah, they need to. In the case of the default, the default implementation is it's random.
Ah, so when it's random, I don't care about partition, so I don't need.
Exactly. Well, yeah. Or if you have only one partition. So the implementation. Well, the important thing there is as they have a way of implement how to decide which partition you want. It gives you the possibility to choose how to partition the data.
Why would I like to choose partition?
If, for example, I mean, I can think about different. If you need one topic for, I mean, as your flow is, if you need one topic, you can probably want, if, in the case of parks, if you will have more messages from one park from other parks, you will probably choose to have 2 or 3 partitions for that park and less partition for others with less data. So you can consume, then you will have the consumers consuming, because the consumers also consume topic and partition in that case.
Okay, so basically we could specify a
So you
part
can-
with partition 1 to 3. The data is going to get replicated, but we know that the message is going to be fetched from these 3 partitions, so we consume from these 3 partitions always.
And you will have 3 consumers consuming from that in the case that you need more power to process the data. So I will, for example, do that.
So
I mean, what I got is that the data is going to be always in this partition, not first in this partition, but always in that partition. And then those partitions will be first in the leader, and then just for replication, in a master slave model, will be in the other servers in the same partition. Replication.
what
Right?
do you mean with consume? Only read or read and consume? Delete.
No,
You don't
no.
have-
This is another thing. It is a commit log, so it's persistent, and you can specify.
To delete.
No, and you won't delete it. You won't delete it. The consumer only reads.
You will have to truncate one day or the other. Right?
Someday you will.
Yeah, someday I will need to truncate.
You don't do it. You specify configuration how long you want the data to be there.
Or
It doesn't matter if I truncate
As
or
a-
you truncate.
or the
As a client,
someone
as
is
a
gonna
client,
see-
it's not like
someone is-
delete puppy because I don't want it anymore.
Yeah. But someone is gonna do some truncation sometime.
exactly, yeah. You can specify that you want the data to be stored for 1 week
Days,
or until it reaches
certain amount.
1 gigabyte. I don't know, or
Or can I
terabyte.
make a FIFO pipeline, something like that? Like I want you to use 1 terabyte.
Yeah,
Once
exactly.
you fill the terabyte, start deleting old, getting in new.
And another important thing is this configuration is per broker, but also per topic. So you can have different topics and you can have different time there.
Because the login topic is, of course, not going to consume as much data as pictures topic, for example.
And not for partition?
Sorry?
The configuration is not for partition?
For partitioning, we have a specific topic configuration for
So
partitioning by topic.
It's
What,
always integrated from topic, yeah? Or you cannot specify configuration per partition. What's physically partition? Because this is what I didn't get.
Yeah.
What's
Yeah,
physically
no.
partition?
we need to look into that. I need to look into that.
Because, yeah, I think it's correct. Because I thought probably it's like hanging on the disk, kind of. But I'm not sure if I understood it correctly.
But I got it the other way. I got it that it's more like something logical. You have different servers, because then you are going to replicate it as well. So I guess that is a concept used to be able to distribute the broker itself among several servers inside the cluster.
But why
So you
have
can-
that on-
It's a distributed system.
It is distributed.
I mean, this is thought for hundreds of services, millions of messages.
So what you have, sorry.
So you have certain limitations. The thing is, you've got certain limitations in those levels. You have the KC.
Right?
You need more than 10,000 connections per topic.
So what you are going to have is, if you have
No, representation.
no problem, 2 servers, you have broker 1 and broker 2, and you
You
have
have 8 servers.
So here broker 1 will be the leader for the partition 1, and broker 2 will be the leader for partition 2, but it will be replicated. So in case that
one falls,
if
the other one.
this one fails, the other one will be leader for both partitions.
But how do you know the number of partitions? So
Well,
the
it
maximum
doesn't-
cluster size at the beginning specifies the number of partitions.
You specify the number of partitions per topic when you create the topic, or they will get the default number of partitions for the broker.
And you can have them something like that, like Cassandra, like having just
Yeah, you
some
can
brokers
also
with some, other brokers
Exactly.
with others, and all these.
And is the data replicated to all of them, or it's just like, for example, you have 5, only 3 replicate?
you can set a replication factor, which is the number of servers where you can replicate that. It's the number, but then you can add via a JSON configuration file. You can write a JSON format file which will say I want this partition to be in this server and so server. This is command line configuration.
Because you said that you can actually wait for acknowledge from the system. When you say the acknowledge, it means you can wait for until the message has been replicated, or you can only wait until
Exactly.
one
There are three possible configuration for acknowledgement. The first one is no acknowledgement, not at all. The second one is I want the leader to tell me that he got the message, and the other one is tell me when the leader has it and it's already replicated in all the followers.
So only one broker can be the leader of one partition.
Yeah.
I guess that's actually the point of having partitions.
Yeah, but that's
this extra layer
that's
complexity,
the
so you can split the load among different servers.
that's kind of
For the
standard
same
now.
topic. For the same topic.
Exactly the same. Brian is exactly the same.
Because you split the topic
I think that's the only way to
across
avoid it
servers.
until
partitions.
scale.
So this is the idea, and we use partitioning for replication, so it is fault tolerant and for distribution as well.
Is there a recommendation or some minimums that they say on the website? Like, we just don't recommend you to go live without minimum fee.
1 gigabyte.
No, then they also
20
say
megs at least.
you can use only one server. It's
Okay.
perfectly okay.
So I
But
want to ensure that a message is consumed exactly one time. How can I do that?
No,
I think you shouldn't be able to. You cannot do it. It's
Yeah.
you cannot do it.
As
I
a
mean,
publisher, you don't know when the message is consumed.
Yeah, but I want
I feel
this
like
message
that's-
only to be consumed one time. Because it's something like inserting a
And
thing into a database.
that's the thing. When you are on this architecture, you must ensure that you make that the messages are going to be
Sorry,
produced in that
again.
unique way, and it's only going to happen once. For example, if you need to create an ID for the image, it's the publisher the one that gives an
Yeah.
ID, not the consumer.
Yeah.
So when you insert, the ID already exists. You don't need to insert again.
Yeah, but other message queues could ensure.
Other message queue system.
Yeah, I'm pretty sure.
imagine that you have
Yeah.
something you have something like that. I don't know if you can see it, but the publisher is pushing to Kafka and the consumer is pulling.
Yeah.
It's not the server that is pushing and waiting for acknowledge. So
The thing is, you can always knowledge that to the public, to the consumer, i.e., to the publisher. You can be publisher and consumer. You can send back a knowledge to the system, and that knowledge is going to get to the publisher that for that topic. And
But I think
validate
that in that case
Exactly.
scenario, you're probably using the wrong system.
if you
Because
do
you're
that,
not
yes.
using not using publisher subscriber, you are using server client model.
Yeah.
So
exactly, the scenario is many messages being
Depends, 'cause you
generated
can do the validation
every time.
on the first publisher, it's still being asynchronous. It doesn't need to wait. I publish all these images, okay, and I expect within today I'm gonna get messages that are related to the new URLs of all these images. If that didn't happen and fail, I can send them back again.
for
And
that,
it's asynchronous.
for that-
I'm not waiting.
For that, you don't even need a broker queue.
For that, if you don't use a queue, then you're gonna be blocking until you finish. And
No,
have
you can
record.
use a brokerless queue and just wait asynchronously. You don't need the heavy weight of a broker queue.
You don't want queue at all.
I'm talking about queues, but
Yeah.
not broker queues. I'm not in a subscriber mode. Because I think that you can find better solutions than overkilling
Yeah.
having
But the question
clients
was
with
actually
publishers.
to answer that.
Huh?
And how to solve that. So don't use this.
Yeah, I haven't noted to discuss later.
Okay, so now we started, but we are going to go a little deeper, not so deeper, but in replication. So Kafka replicates the log for each topic partitions across a configurable number of servers. The unit of replication is the topic partition. Total number of replicas, including the leader, constitute the replica factor. So if I have 4 servers and I want a replica factor of 3, it means that I will have 1 leader and 2 followers. Only that. All reads and writes go to the leader of the partition. The log and the followers are identically to the leader's log. This is another thing that you can detect that a follower is not working anymore because of the difference between the last time it reads from the server. So Kafka ensures that. So you will need that the server is down because of that, and it will rebalance. This is another thing when the leader is down, then rebalance the system so a new leader for the partition comes up. A message is considered committed when all in-sync replicas for that partition have applied to their log. Only committed messages are ever given out to the consumer. So the producer doesn't know, but only committed messages are given to the consumer.
Oh, fuck. That means that an issue in a follower, I've got a follower down, so it's not consuming. Therefore, my consumers are not consuming either. So the whole thing is fucked.
No, because probably the system as a whole, as a cluster, will see that.
I mean, I will have the data, but
You will still
You
be
mean when one of the,
I
brokers dies?
I mean, yeah, if one of the followers is down, is that considered one sync replica less?
No, if it
Or
is
is it
considered,
still-
I mean, imagine.
Still considered a sync replica
Well,
and
that's-
waiting for it to
the
come back.
rebalance is basically.
But yeah, that's
When you do the rebalance, basically you are using the other one as followers. This one is intact.
Exactly.
Anymore, and you have all the data. Anyway.
When Kafka notices that is down, it is automatically no more a part of the
You
in-sync replica.
Yeah,
you
so it
stop
makes
having
sense.
3 followers, you have 2. That's all.
Okay.
Still working,
Yes.
and you have if you have monitor system, you still know.
That's like it.
Eh?
That sounds like it.
All of them work like this.
So the guarantee that Kafka offers is that committed messages will not be lost. So we can't make sure that it will be consumed only once, but once it is committed, it will be there. And if a consumer has a problem, as the consumer also manages its own offset of the queue, it can go back and reprocess this message, for example. And this is a slide from Apache Kafka, which has lots of these cases and explains it a little more. So I don't know, any questions about replication or something like that? I don't know more than that, but
When are you going to say all of this in English?
sorry?
When are you going to say this in English?
To say what?
Yeah?
She's joking.
Ah, sorry. Well, we have lots of parameters in the configuration of broker, consumer, and producers, but those are mandatory. So in that case, for the broker, every broker has its broker ID. The logs directory is where Kafka is actually storing the data. And it handles the cluster through Zookeeper, so it needs one or many IPs of the Zookeeper cluster to communicate and to manage the cluster. From the consumer, we need the group ID. So this is another thing, consumers. This is another thing that is good for fault tolerance when we talk about consumers. That for consumers, we have the concept of consumer group. So the offset of every consumer is stored in the consumer group. That means that two consumers cannot be reading the same topic partition at the same time. So it's the consumer group which will handle which of them is going to be consuming the partition. So when a consumer goes down, it rebalances again the consumer group, and the other consumer can start consuming from this partition.
So it's like multi-threading. It's synchronized reading, like having a mutex, something like that.
Yeah. In that case, they do that through Zookeeper. Yeah, that's true. The idea is that when they all are going to register against the cluster, and the first one is going to read, and the other one are not allowed to read against the first one is down, it will detect that using Zookeeper's heartbeat. So this is all managed via Zookeeper. So this is another interesting thing about consumer. It doesn't mean that you will only have one consumer. You can have fault tolerance, and you can have fault tolerance by assigning to consumers the same consumer group. If you have another consumer group, I mean, you can have something like that. You can have something. Yeah.
So is that the same partition replicated?
I mean,
second one?
Different consumer groups, different applications, completely different applications. They can read the same partition. It can be subscribed to the partition. But in the same consumer group, only one consumer can read the partition.
Okay, so you cannot that. Then you can manage the synchronous processing while not replicating or not having 3 times the same methods.
Exactly.
One question about for balancing. What's the status of the system when it's for balancing? Because I know, for example, Elasticsearch when it's for balancing, you have like system becomes quite slow, and it's quite a challenge on some of them. I know Postgres can get fucked up and end up out of system for 8 hours, and you don't even know why. So
they say that there is no downtime, and that the system
it goes down. I think
doesn't get slow, but I'm not sure about
I actually think in Elasticsearch it used to be block writing while rebalancing, so you couldn't write. Much standard that. I don't know if that happens.
I don't know, but I can investigate that.
Or theoretically, if you already have slaves that have the messages committed and everything, you should be able to switch.
But when it's rebalancing, it's actually
in a similar fashion to HA.
When it's rebalancing, depending the number of replicas you have, they may not fit
How can it
on
ensure
on one place, and they should be
He's
now.
writing atomically.
For example, if you have
If
6
there's no
nodes,
database,
you have
this
6
can
nodes.
break
You
or
have
something like this, and there's no rolling back plan.
You have these three replicas. You have 3 replicas.
If you have a
in each one.
database,
Okay, so
it manages
you
these
still need
cases,
at least
so
3
you
of
don't
them
have
have
to be able to
transactions
have all
because
the data.
every single change.
But when you go and do
Exactly, but
rebalancing,
one
you
computer,
can distribute this again.
while the disk
Some
is
cases
writing
you need to replicate
something that
and 4 replicas
you
to
can
one node.
would have a breakdown or something like
And
this.
it's
Or,
all the system is
Are you
working,
sure?
stopping
So
thousands and
what you
thousands of
can
messages
have
from
is-
one place to the
I
other
mean,
one.
if the,
Yeah,
if the data fails,
It's like
you will notice
You don't have to
if you want
log
the
your
knowledge
or something
you
because
will
you only
notice that and you try, and by the time if the leader is down,
Yeah,
you
it's
rebalance and you will have
Yeah.
another
You
leader.
need to learn
Or
it.
what you can write.
And always with
I mean, it's
binary
it is distributed, so
I don't know.
really
It's nice.
Yeah, I see this
For an hour.
so okay, he get the message that is being written after it has been written.
This was the
Right.
and it's interesting.
That system that pretty good.
So
Really stable 90% of the time, 10%.
sorry. So well, as I said, the consumer. I introduced the concept of consumer group, which I haven't introduced before. Then the zookeeper, where consumer is going to be connected to, and in the producer we have the broker list. First, we need to pass that value to the producer, so the producer will know where the Kafka cluster is. We can send all the IPs of the and ports of the members of the cluster, and then it gets the metadata from there, and then really starts the communication with Kafka. Then this is the configuration part that I told you about the ACKs. So you have 3 levels. 0 means no knowledge at all. 1 means only the leader. -1. Producer type, it can be synchronic or asynchronic. If it's asynchronous. If it's asynchronous, it means that it will hold as many messages as it can and then send them all together. Exactly. And the serializer class is the class that we are going to use to serialize the message that we are sending to another application, or to the queue. So
Could I know more about this, the requirements of this serialization? We can do it. Or? No.
So
It's advertising company?
I was planning to do a demo, but as we are like 42 minutes, I don't know if you want. Yeah. Okay. So let me see. I need to find first.
You were not ready.
Yeah, of course I am. Look. Oh. Come on.
Oh, amazing. Now we can.
Now it is.
A
How can I?
lot better.
Come on,
You're fixing it.
No, this
Maybe
is-
that.
You're fixing it. You're not user. Just don't try.
Don't touch it.
the shape is.
Just drop an apple in the logo.
Yeah. Just leave it. Doesn't really matter. And now we have a keystone there in the middle that right?
It's going to disappear in few hours.
Sorry, what?
Yeah.
You can modify the size of the.
Yeah. You tell me how you.
No, I don't want to press that.
No, but here probably. I don't know how to.
You or
What
do you want to do?
Control
Okay.
plus is
size
on
of
Control plus.
To the side.
Okay.
No,
Yeah.
No, less.
PS1 equals.
It's the same for it. So first of all, we need to start Zookeeper.
Wow.
Oh, it's not.
That was an insult, Micha. How can you talk about that? About my mother? Say this kind of stuff. So after running Zookeeper, now we have Kafka broker working, right? We have it running.
Why?
Do the demo.
But this is static or I can do this?
To do the demo, Michal. Thank you. We are supposed to be in the same team,
Good
Michal.
morning.
Yeah. That's my coffee.
It's Monday.
Welcome to the office.
We have a standard.
So now the idea is to create one topic so we can produce messages to that topic and then consume that as an example. So
Hot topic.
hot topic.
A topic.
Let me.
We're starting with a complete empty log now.
Sorry?
We're starting with a complete empty log in the Kafka server.
I restarted. Yeah, I started with
With zero.
it is empty right. Yeah, right now.
If not, we can always create a new topic.
Yeah. So well, here it's the command to create a new topic, which we are passing at the end with a replication factor of 1, which is also the default for the broker. So it's not necessary to pass the replication factor or the number of partitions that we want. Also, if we want a topic with only one partition, we don't need to create it at all. The first message you get with this partition, it is going to create the topic.
Would you mind partitions if you were creating more partitions? Because you might
You-
identify partitions, so
You can add them.
like about 9? Would you do 9? Or
No, you have the number of the partition.
just a number, okay.
So here we can write to our newly created topic. So all those are
Yeah, it says doesn't like topic.
I like it.
Doesn't like
Just
topic.
a warning.
Oh, I like it. No, I didn't write anything. I'm preparing. So well, yeah.
Message 1. Are you ready?
You're right. One bar.
Yeah, full bar path.
Yeah, or hello world.
That's fine more developer likes.
Hello world, pues he's a hunter that I
So now we have our consumer that is consuming from the beginning. So we have all that we produced, all the messages we have here. Oh. Sorry.
Might could split the windows.
Yeah, this is another good idea.
So you specify from beginning now. Okay. You specify something different.
And you can set the position of in the offset, but I don't know the position right now. So,
But can
yeah,
you,
but you
know,
can.
But it's like, can you say use like from 3, something like that? Skip the first 2 messages or something like that? Or?
Let's try.
but
I don't know.
can
But
you
let's try.
register some events to get the message?
You are registered to the topic. The topic in this case is it's what we are
Okay.
we are
Can
following.
you have that is waiting for new messages.
Can we do that? From end? From end? No.
Can you just not put anything and probably get the font? Yeah.
Let's see.
Now try the other one. That looks right.
Oh, so yeah, okay. So it's good.
It's the 4 latest.
And you now just clean the docs and try again from the beginning. See if it's still getting.
All these scripts come with the tool set of Kafka.
Yeah.
Yeah,
Again from the beginning, or
yeah, but clean the docs so we can prove that actually it's not cheating.
no? What? How?
Someone else is not writing it. I don't know. Who's this in there?
Yeah?
Someone else might be writing that they might like agree
Yeah.
to us.
For what? I don't.
Open the computer and connect to this computer. I'll send some message.
So what do you want to
Put the sound.
I want you to
kill the producer or what?
kill Kafka.
Oh, we can kill.
Don't kill him.
What the fuck?
It looks quite dead.
What the fuck is that?
And what happened to the
Oh,
consumer?
That looks nasty.
Because of our
That looks very nasty.
You should check that doesn't exist. Now you can start Kafka again.
No workers found. Trying to rebalance.
Yeah, you can.
Yeah.
In that case, we may.
Yeah. And it was waiting for
zookeeper consumer.
no brokers found when trying to rebalance.
Oh, there you go. It found out all of it.
Without a restart.
Cool shit. Cool shit, yeah. But
Now we need that bigger.
If we need a bigger demo, we can do a project.
I think that the way to
Our
go
training
is. I think that the way to go, the next step would be just to continue with the project. I prefer to be hands-on and do a small. Yeah. Give an example. Are we done with the demo?
Yeah.
If we're gonna start talking specifics, we cut down the YouTube.
Okay.
So yeah, thank you, Nicolas. Yay! Woo!
Hey.